Hi, welcome to AP Calculus for East Aurora High School. Today in Chapter 2, Section 2, we're going to practice rewriting functions before differentiating. Sometimes it's necessary to rewrite a function algebraically before taking the derivative using the power rule. So we want to be able to write all of our functions so that the power rule will be applicable. In example number 1, we have y equals 6 over x squared. So before we can use the power rule to take this derivative, we are going to rewrite it. So we're going to say this is the same as y is equal to 6x to the minus 2. When I rewrite the function in that form, I see that now I have a variable raised to a power, so I'm going to use the power rule. So for the derivative, we're going to bring the negative 2 down and multiply it by 6, so it'll be negative 12. X to the, subtracting 1 from the old exponent, I get x to the negative 3. Now, one of the rules that we're going to follow throughout calculus is that our answers cannot have negative exponents in them. So we want to continue on and simplify this answer as negative 12 over x to the third. So this represents the derivative of the function y equals 6 over x squared. Let's try example number 2. This time it's y equals 8 over 3x to the third. Now be very careful when you're rewriting this function. Again, I see that I have x to the third, this time in the denominator, so I'm going to rewrite this as the coefficient 8 thirds times x to the minus 3. So now it's in a form where I can use the power rule to take the derivative. So the derivative is going to be equal to, the power rule says let's take that negative 3 and multiply it by the coefficient 8 thirds. So negative 3 times 8 thirds gives me negative 8. X to the, subtract 1 from the exponent. Be careful when those exponents are negative. Negative 3 minus 1 gives me a negative 4. Again, following our rule so that we do not have any negative exponents in our answer, we're going to say this derivative is negative 8 over x to the fourth power. In example number 3, we have y equals 4 over 2x to the third. So we need to do a little bit of work to rewrite this function to get it in the form of a power rule. So I'm going to say let's do that exponent in the denominator, so I'm going to have a 4 over 2 to the third power is 8, x to the third. Now of course that can be reduced, so now I've got 1 over 2x to the third power. And when I rewrite this, I'm going to say this is the same as 1/2 x to the minus 3. Now don't get so excited that we've rewritten that you forget to go ahead and take the derivative, because the goal here was taking the derivative of this function. Now it's going to be a lot easier using the power rule, so we're going to say y prime is equal to, bring down the negative 3 and multiply it by the coefficient, so I now have a negative 3/2 x to the negative fourth power. And again, let's simplify this answer, so my final answer without a negative exponent, any x that has a negative exponent is going to move to the denominator, but the coefficient stays the same. So it's negative 3 over 2x to the fourth power. So really we're just practicing some algebra today, but we're practicing important algebra that helps us to do calculus correctly. In example number 4, this one's a different form. I don't have a rational function this time. We are going to see another method a couple units from now that will allow us to take this derivative without rewriting it. But for us today, it's going to be required to rewrite this. So let's go ahead and square the 2x minus 5. Remember our simplification of a binomial squared? We square the first term, so that's giving us 4x squared. We double the product of the two terms in the binomial. So 2 times 2x times negative 5 is giving me a negative 20x. And then we square the last term, so that's going to be plus 25. Of course, you could have multiplied these out using FOIL or double distribution as well and gotten the same trinomial. Now we're ready to just go ahead and take our derivative. You'll notice that I've got addition and subtraction, so I'm taking the derivative of each term separately. 4x squared, derivative 8x. Derivative of negative 20x would be negative 20, and the derivative of 25 would be 0. So this derivative was quite easy if I first of all simplified the binomial squared. In example number 5, you see that we have division this time. So if I've got division, I can go ahead and divide each term by x squared because I've got a monomial in the denominator. So 4x to the 5th divided by x squared, that's giving me a 4x to the 3rd. Negative 2x to the 3rd divided by x squared, that's giving me a negative 2x. 5x divided by x squared, well that of course is going to be 5 over x, but 5 over x is the same as 5x to the minus 1. Again, all I've done is rewritten that function. I haven't taken the derivative yet, so let's go ahead and take the derivative using the power rule. The derivative of 4x to the 3rd, 12x squared. The derivative of negative 2x, negative 2. And the derivative of 5x to the minus 1, negative 5x to the minus 2. Let's go ahead and rewrite that answer without a negative exponent. Now be careful, this is sometimes a misconception. Students sometimes think that they're going to put that x squared underneath all three terms. That would not be correct because the only term that has a negative exponent is the 5x to the minus 2. So I'm going to leave my answer as 12x squared minus 2 minus 5 over x to the second power. So there is the derivative of that function. In number 6, we also have a division, but this time we're dividing by radical x. So of course this is the same thing as 8x squared plus 6x minus 12 all over x to the 1/2. Again, remembering what we do when we divide by a monomial, we're going to subtract our exponents. So I'm going to say 8x to the 2 minus 1/2 gives me 3/2. Plus 6, x to the first divided by x to the 1/2 would be x to the 1/2. Minus 12. Now my x is going to have a negative exponent because the 12 didn't have any x to divide it by. So here is my rewritten function. Let's go ahead and take the derivative. So 8x to the 3/2, when I take that derivative, let's multiply the exponent 3/2 times 8. That's giving me an answer of 12. So my coefficient is 12x. Subtracting 1 from the exponent, I now have 1/2. 3/2 minus 1 is 1/2. Go to the next term, 6x to the 1/2. Multiply 1/2 times 6, and that gives me 3. Keep the x. Subtract 1 from the exponent, so that's going to be a minus 1/2. Finish it off with the minus 12x to the negative 1/2. I multiply the exponent times the coefficient. So that's going to be plus 6 x to the, subtracting 1 from negative 1/2, that's giving me negative 3/2. So I now have as my derivative 12x to the 1/2 plus 3 over the square root of x, or x to the 1/2, plus 6 over, this would actually be x radical x, because you've really got x to the 1/2, x to the first and x to the 1/2. Sometimes in your textbook you'll see where they find a common denominator and add these terms together. So our common denominator for this trinomial would be x radical x. So in the entire thing, if I multiply the numerator and the denominator by x radical x, in order to get a common denominator, I'll see that for my 12, x to the 1/2 times x radical x would be 12x squared 3 over radical x when I multiply by x radical x. And again, what I'm really doing is getting every single term to have a denominator of x radical x. So in this case, I'm going to say plus 3x. And then my 6 actually already has the common denominator, so I don't need to multiply that one. But then they would all have the denominator of x radical x. So I can either say that my answer is in this form, let's write that as a derivative, or I could have left my answer in this form right here. Both of those are equivalent and acceptable. Now I'd like you to take a few minutes to try these 2U try-its. When you have finished, so pause the video while you're working, and when you have finished, restart the video and compare your answers with mine. Welcome back. Compare your 2 answers with mine. In U try-it number 1, I rewrote the denominator first as 16x squared. That allowed me to cancel the 8 with the 16 and get 1/2 x to the minus 2. In that form, I could then take the derivative using the power rule. So multiplying negative 2 times 1/2 gives me a negative 1 x to the minus 3. But rewrite your answer so that it doesn't have a negative exponent. So my derivative should be negative 1 over x to the third. For number 2, I've introduced a radical x. So that's really going to be x to the 1/2 distributed through the trinomial. So do that distribution first before you go ahead and take the derivative. You'll notice that I've color-coded all of my examples in these notes, so the black lines are always the original function. The blue are always the derivative. So I have 4x to the 5/2 by adding exponents together, minus 6x to the 3/2 plus 10x to the 1/2. Go ahead and take the derivative then in that first blue line. So multiplying 4 times 5/2 gives me 10x to the 3/2. I subtracted 1 from the exponent. Multiply negative 6 times 3/2 and that gives me negative 9x. Subtracting 1 from the exponent gives me a 1/2 for the new exponent. Lastly, 10x to the 1/2, I'm going to multiply 10 times 1/2 and get 5. Subtract 1 from the exponent and that gives me a negative 1/2. Rewriting this answer, I've rewritten it in 2 different forms. The first answer, I just moved the x to the 1/2 underneath the 5 so that it would have a positive exponent. Or, if you want to put these 3 terms together with a common denominator of radical x, I need to multiply the 10x to the 3/2 by radical x on the top and the bottom and get 10x squared over radical x. Also multiplying the 9x to the 1/2 on the top and the bottom by x to the 1/2, and that gives me 9x over radical x, plus the 5 already has the radical x in the denominator. So either of those last 2 lines would be correct and equivalent solutions. Thanks for practicing with rewriting functions in order to use the power rule to do the derivative today. You'll notice that some of your homework is on these very same types of problems, so hopefully this was helpful so that you can work on the homework problems. Have a great day and we'll see you next time. Bye-bye.